Hey math kids, today we're going to talk about graphing cubic functions. And so first off, a cubic function is something that has a leading coefficient that looks like this. So x cubed, and if a is greater than 0, meaning positive, then it's going to look something like this, where it starts going down and then on the right it's going up. And then if a is less than 0, it's going to be flipped like that. Okay? And all the other transformation stuff just kind of applies. So let's jump into a example and just see how it goes. So if we're thinking of the original function being y equals x cubed, they want us to graph y is equal to x minus 2 quantity cubed minus 1. So what we're going to do, we're going to start by drawing this function. Since the a out in front is technically a 1, that's positive, so we're going to get a function that looks kind of like this. Alright, now this negative 2, that's going to shift to the right 2. And this is going to go down 1. Okay, just like all the other transformation lessons we've talked about, it's kind of the same thing. I like to move the origin point and then just redraw it. That's how I do it. So 2 and then 1 down, moving that origin point, and then just kind of like redrawing what we have. So it's going to be something roughly like that. Okay. Now, that's just kind of the basic idea of that. Now we're going to try y equals 2, x plus 3, x minus 1, x minus 3. Now, when we're doing this, we're going to graph a couple points. We're going to graph the x-intercepts. So first off, pull those out. So the x-intercepts are just going to be the opposites of these numbers. So negative 3, positive 1, positive 3. So I'd start by putting points right there. 1, 2, 3. 1, 2, 3. Okay. We can also pretty easily find the y-intercept. So if I plug in a 0 for all these x's, I'm going to get 2 times 3 times negative 1 times negative 3. These negatives will end up canceling. 3 times 1 times 3 is 9, times 2 is 18. So we have a y-intercept at 18. Alright, 18's all the way up there. Now, we also know that our a value is positive. So we know that we're going to start down and then go up like that. Now this can be more exaggerated. It can be like this. But we just know it's on the left it's going to go down, and on the right it's going to go up. And so when we sketch this, we just know we have to start down and then we're going to go like that. So we didn't do anything to find the max and the min, so it's okay if it doesn't quite look how the book looks. We just need to make sure that the intercepts are correct and that we start down and then end going up. Okay, later we'll learn how to find exactly where those maxes and mins are. Okay, now we're going to do that again. So we have negative x minus 2 quantity squared, 2x plus 1. Okay, so these x-intercepts, we'll start with those again. We're going to have 2 at 2 because it's squared. We have 2 there. And I'll explain what that means. in a minute. This one, if we do 2x plus 1 equals 0, we end up with x equals negative 1/2. Okay, those are our x-intercepts. We're going to plot those. So something's going to happen there, and then 1/2 is about right there. Negative 1/2. Okay, we can find the y-intercept by plugging in zeros again. So we're going to get negative on the outside, negative 2 squared, and then we're going to get a 1. So that's 4 and then negative, so y-intercept is negative 4. Okay, so we have that. Now, we also know that the a value is negative, and so that's going to be this type of shape. So we're going to start from up here, come down, go up, and then end up going down. Now, whenever we have a double, like a repeated root, that means it's not going to cross through this one. It's just going to touch it right there. So we're going to come down like this, touch it, and then go away. Okay? So that's the basic idea of how to graph cubics. Now, we have one more example though. It says find the equation of the cubic which cuts the x-axis at 2. Okay, so we have x-intercepts at 2, negative 3, and cuts the y-axis at negative 48. And which passes through the point 1, negative 40. Okay, so let's write down like what we know. So we know that we have an x minus 2, we have an x plus 3, and then we have some other linear factor. So we're just gonna, ax plus b, something like that. Now, we also know the y-intercept, so if we plug in a 0 for x, we know that y is equal to negative 48. So we're going to do that. And that can give us our b value if we do that. So we have negative 48 equals negative 6b. Divide by negative 6, divide by negative 6. We end up with 8 is equal to b. Okay. Now, we also have this point, so if we plug in a 1 for x, we know that y is negative 40. So I'm going to do that. And I'm going to plug in my b value as 8. Alright, so we should be able to solve for a when we simplify this. So we get negative 1, 4, a plus 8. That's negative 4, a plus 8. Divide by negative 4. So we have 10 is equal to a plus 8. Subtract 8, and a is equal to 2. Okay. And so if we do that, we can replace both of these. We get x minus 2, x plus 3, 2x plus 8. Now, if we want to write it completely factored, we can factor out a 2 right here. So put the 2 out there. If we take out a 2 here, it's just x. Take out a 2 here, it's 4. So there's our final equation. If you need extra help, please come to Math Lab. Until then, calculator.